If only it existed a way to move DC motors, simple DC motors, with the Raspberry Pi, without any hassle, without soldering, without wires flying around, and cheap. Welcome to MorpheusChair, the program where you learn how to build real robots like these in your comfy chairs. Thank you very much for your support in the previous video. We are super pumped. Thank you very much. So, as promised, let's get this baby moving. In this program, we are going to learn how to move this robot with Raspberry Pi and a special hat that it's called RPI MotorDriver board, but basically we're going to call it the H-bridge hat because basically that's what it is. So before we start, we are going to list here the bill of materials. So the first thing you need is the previous build that we did, so the base with the motors, the wheels, and so on. If you haven't seen the previous video, check it out and then come back here. Then we will need a Raspberry Pi Model 3B. We will also need, of course, the H-bridge board that we call that. It's the RPI motor driver that I leave in the description below where to find it and all that. Then we will need some jumper wires like these. We will also need some AA batteries, 4. We'll also need a female jack connector and probably a male also for some tests, like these. We will also need an HDMI cable, a screen. We will also need a keyboard of some kind and a mouse. You can use standard or the one that I left in the description below, which is an integrated keyboard like this with mouse and keyboard all integrated, so it's compact. We will also need a micro SD card of minimum 16 gigabytes of memory. It can be bigger, but as I said, keep it simple and keep it cheap, because if you ruin the micro SD card, is not the same paying 10 euros than paying 50, okay? So bear that in mind. And finally, you'll need some kind of PC to do the operating system installation. Apart from that, everything else you can do it with the Raspberry Pi. All the materials that you'll need in this session, I've left it in the video description below. Please, I highly recommend you that you see the whole video and see exactly what you'll need, because for example, I needed an extra element, which is a HDMI to VGA converter, just because my screen wasn't HDMI compatible because it's too old. But you have to see, because maybe you don't need as much stuff because you already have it. So take a look, yeah? Okay, so I've divided this video into 3 main parts, which are the operating system installation, UbuntuMate, then the wiring and the installation of the build, the physical build, and also the programming part, where we explain a bit the code that we are using to move this bad boy, and also just a tiny demo of what it is, how it moves basically, yeah? So take a look, yeah? And without further ado, to the workbench, 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 to the workbench. So in this first part of this Robo build, we are going to install the operating system in Raspberry Pi. So Raspberry Pi has its operating system loaded through a micro SD card, and we're going to burn in a micro SD card the operating system. In this case, I've selected UbuntuMate. The reason why I'm selecting UbuntuMate over Raspbian is for basically one reason. UbuntuMate is much closer to stock Ubuntu. So you can use practically everything you use in your nice old Ubuntu. It's simple. So first step. The first step is you have to go to ubuntumate.org and here select download and go to Raspberry Pi, select it, select the version, in this case 16, and then you select download. In this case, I highly recommend you that you use a torrent. It's much faster and you'll help the community in some way. Download, and then you open the torrent and you download the file. In this case, I've already downloaded the file and we have it here. So it will be something like this. And this is the file that we're going to burn into the micro SD card. Now that we have our operating system downloaded, we just have to get our SD card of 16 gigabytes. It can be bigger, but I recommend this size just because it's cheap and it's enough for what we want. Okay, so yeah, there we go. So now we just have to get the SD card, the big one that comes with the micro SD card that we buy. We introduce it like that, and then we put it inside our SD card reader that we have in our laptop, or we can buy a dongle to read this kind of cards. Once you have inserted the SD card in your PC or laptop or whatever SD card reader, you'll have to open the application in Ubuntu that it's called disks. There you go. So now you'll get something, a window like this, and if you see your 16 gigabyte SD card will appear there. You select the file, the image that we just downloaded, and there we go. So you check and you hit start restoring. You say, do you want to do that? Yes. And you type your password. Okay, now we will have to wait until it's recorded. And there you go. So we just are quite finished now. So there we go. We now have our operating system installed. And as you can see, it has different parts as an operating system should have. Okay, once we have the system installed in the micro SD card, we now have to introduce it in our Raspberry Pi. There's a tiny slot here and you have to insert the SD card with the picture on the top. Let's say the colors and the numbers here, and it should be just like that. Okay? Be very, very careful with the SD cards because they are really fragile, especially the micro SD ones. So it's good if you spend 50 euros in a 120 gig. It's not the same as one of 16 gig. Okay, so again, cheap. Then I highly recommend you that you buy these official supports for Raspberry Pi because they go really handy in protecting your system. You just have to assemble it like this. So you go here, and this is the most delicate part because you have the SD card there. So you have to introduce it like that, and then bam, you have it. Okay, don't press, don't do anything very fancy, just it has to be very, very correct like that. Okay, it's perfectly like that. And then we can assemble it. This part goes like that. We assemble it like this. There we go. Again, be very careful not to press too much. Okay, we have that, and then here we have to hear like a click. That's it. But it as you can see, I'm pressing very, very light, gently. Yeah. Then we can put this lid on, which protects the system even more. There we go. Okay. Always keep an eye on the SD card, and then we can put the supports here. There we go. 1 and 2. And this would protect the whole system. Like that. There we go. Okay. So now we have our system ready to be booted and initialized. So let's go to the last part. What we're going to do is connect our Raspberry Pi to the HDMI that we have here, and also to the micro USB brick that is official for Raspberry Pi. So you can see it's the official one. Then we are going also to connect the Bluetooth keyboard that we will use for the configuration, and we will connect it to an HDMI that in my case is a VGA converter. Okay, so the only thing that just to note is that because it's a Bluetooth keyboard, we have to put this Bluetooth dongle. So this last part is the most simple one. You just have to power on the brick for the Raspberry Pi. When you just plug it to the wall, it will start up the Raspberry Pi, and having the Raspberry Pi connected to the HDMI, you'll get something like this in your screen. There you go. So now one of the first things you have to do is select the Wi-Fi, set it up, then you'll have to select the time zone, and also now you have to set up all the username and passwords, and you'll have just to follow the instructions, and you'll have the operating system UbuntuMate ready to go. And now the final build. So now what we're going to do is do all the wiring and the assembly of everything so that we can go to the last part, which is programming the command, the program, basically the Python script to make these wheels move. So I've just removed these screws from the top panel that we left the previous video, and what I've done is I've marked, differentiate one wheel from the other with some electrical tape, because we will need it afterwards to know where we are going to wire it. It's just provisional, just to do the wiring, and then you can get it out if you want. I've placed some AA batteries here, and if we want to test the wires, we could, for example, do this. So I'm placing this here, and I press, and then there you go. So this, the blue one, it's the right wheels, and these, let's have a look just to test that everything goes. Okay, so without, left, with, right. Okay, so right and left, and you can see that I'm using a 9-volt battery with a male connector screwed and then connected here. It's really handy, and also you get more power and more voltage in a small package, so they are really handy to do tests and this kind of stuff. Okay, the one that we are going to use actually is this one. So I've just bought one of this. I've bought one female and 2 cables that have to have these ends. You can do them raw, but I like them like this because they are just more sturdy. And very important, this is really important, you have to wire it, the red one to the plus and the black one to the minus. And you say, hey Miguel Angel, but can't you, for example, put the other way around? Yes, but you have to be coherent, because afterwards we will have to wire it, and if you don't remember, you can screw up things, especially if your electronics is not that good. Okay, so be coherent, plus red, minus black. So we'll let this aside, but basically it will be to plug to the battery pack. We just plug it like that. That's it. It's really easy. As I said, you have to try to have plug and play solutions. So the first thing we are going to do is pass the wires through this hole here. So let's go. There we go. So now we have the wires for the motors. Now we screw them. There you go. So now we are going to see how we assemble the Raspberry Pi. There you go. So here is our friend Raspberry Pi. So now what we're going to do is place the H-bridge hat on top. So I present you the H hat, and you ask me, hey Mike, why are you using this? Why don't you use other stuff? Sure, there are thousands of options to do this. This, I found it was the easiest one, the fastest, and like price range, it wasn't really expensive. And apart from the neat features like the IR sensor and the ability to use PWM easily, it's also because it's simple. Yeah, so keep it simple. Less cables means less errors, and if there are errors, it's easier to debug and see where did you wire something wrong. If you have to wire 20 cables, it's really probable that you make mistakes. If you only have to wire the minimum amount, it's much less probable. So you just have to align, you have to get the pins and align them and connect them to the GPIO. There you go. Okay. Now we press. There we have it. So now we have the hat installed in the Raspberry Pi. And now what we're going to do is the wiring. Remember, right, left wheel. So we will need not a Phillips screwdriver, but just a plain flat screwdriver. So important, very important is you can see here that we have indications of what to connect. So here is M1, M2, that we will put the left wheel, positive, negative. Here you could put negative, positive, it doesn't matter. Just bear that in mind when you do the code, because then you'll have inverted. Yep. So we'll put positive, negative of the left and positive, negative in M3 positive, M4 negative of the right wheel. Okay. And very important, VC and ground. Here is where we will connect the power. Okay, finished. So please check that the cables don't move, okay? Perfect. So now we are going to connect the power. Not the power directly, this is very important. Never connect the power directly when you're fiddling with the cables. So this is a very good system. So tuck this here so that it doesn't, yep. So we're going to connect the positive to the positive and the negative to the negative. So very important. This is important because in this kind of hat, normally if you screw this up, it doesn't matter because you have a security diode. But don't get used to it and do it right. Okay? So positive to the VCC. And ground. So now, how do we test that the wiring was correct? Well, we will have to do the program first, but if we did this correctly, the power, there we go. So we connect it. And we have a red light just there. There you go, power. So how does this hat work? Basically what we have here is H bridges, 2, 1 for each motor, and it has an infrared sensor that we may use in the future to send commands and send them to the Raspberry Pi, read them and so on, and do whatever we want it to do. And also it has this switch. This switch, in theory, what it should do is that if you put it in on, it should power the Raspberry Pi. We are not doing it because basically I've done it and it doesn't work. Leave it in the comments if you have any suggestion about that. I would love to know how to make this work because it could simplify even more stuff. So there you go. And now the last part is the programming part. And now that we have it all set up, it's time to do some code. We will start with a very simple example, which is basically a simplified version of an example code provided by the people of the H-Bridge board. So I highly recommend you that you code in your own computer where you feel comfortable and then upload the code to a Git This is the Git that I leave public for everyone. And basically when you upload it, then you can download it into the Raspberry Pi and just execute the tests. Yeah. Another way of doing it is coding directly on Raspberry Pi. If you have a comfortable keyboard and a screen, there's nothing different because it's an Ubuntu like anything. So you could code with your IDE. I would highly recommend that you don't use a very big and heavy IDE like Eclipse, but Gedit or Vim or anything similar will be perfect for that. And don't try to connect through SSH or remote desktop. It's too complex. Keep it simple. So let's have a look at the code. So if we go here, I'm here in MorpheusChair Git, and if you go to Raspberry Pi scripts, we have MotorDriver. So let's have a look with Vim. There you go. So it's a very simple code actually, and it's based in the example code that I leave in the video description, all the links to the original documentation of the manufacturer of this hat. So essentially what we have is a main function that starts with a PWM value of 50, and then what we do is we call this method MotorDriver test basic, and we give it this value, and when it finishes we increment it by 10. This will make the wheels go faster each time that we call it until we reach a limit, which is based on software. So for that you don't issue very high frequency PWM basically. Yeah, so you have a maximum, which is good because we can't make the motors spin really crazy fast. So let's have a look at this method. So I have different methods here, but this one is the most simplest one, which is here it only goes forwards and backwards. It doesn't go right, or it doesn't stop basically. Okay, so here it goes to reverse. There we go. Now I can sleep better. So what we do here is we initialize this class that we are going to see right now. We initialize this PWM value. We change the duty cycle, which changes the PWM. And then we call the reverse. Wait 2 seconds. So we go in reverse for 2 seconds. And then we go forward 2 seconds more. And then we finish. Yeah. And if we go to the MotorDriver, which is up here, essentially what we do is we set up the pins, which is this pin is for the infrared sensor that we probably use in the next video or maybe 2 videos. Then the PWM for the motor 1, motor 2, basically this is motor 1A and motor B. And then it's the positive, negative, yeah? And this is for the PWM that basically activates the PWM, yeah? And this is the value. Then we set the mode to BCM. We remove the warnings and we set up the pins, basically. You don't have to know how this works, just have to know that you have to do this. Whoops. You have to do this to make this work. Basically, we are enabling the pins and setting them to out. The same here. Then we are activating the PWM, and here we start. And for the set motor, which is, it's essentially setting the values for the motor that we do for forwards. For example, we set the motor 1010. This means that we activate motor 1 positive, we deactivate motor 1 negative, then, and the same for the second motor. The positive we activate it, and the negative we put it to 0, and this will make it go forward. If we want it to go reverse, it's the same thing but in reverse. Yeah, so we put high the negatives and low the positives, and left, but you can imagine what we have to do. Yeah, and that's it. So now we have to see how we execute this code and see the wheels moving. But you'll say, hey Mike, but when are we going to see the robot move? It's been like thousands of minutes and we haven't moved the robot yet. Calm down, calm down. We'll do it right now. And this is the setup to make the robot move. So as you see, I've set up the HDMI, the power for the Raspberry Pi, and I'm going to power up the Motor Hat right now. There we go. Perfect. You see the red light. And now we're going to power the Raspberry Pi. So I just turn on the switch I have here to give power to the micro USB. I power the screen. I'll power also my keyboard. There we go. So now we have Ubuntu. So we open a terminal and now we navigate to the place where we saved our Git with the tests. Okay, so now that we're here, let's go to Raspberry Pi scripts. Check that they are executable. There we go, it's executable. So now we just have to execute the code. So before we execute it, let's have a look. Bim MotorDriver and see more or less what we have here. So in this case, we're going to execute this MotorDriver test basic, which what it does is send reverse and forward commands and increasing each time the PWM value by 10. And yeah, I think that's quite it, until basically Raspberry Pi says that he can't go faster. So let's get out and let's execute this. Let's clean this. Okay. And MotorDriver. Be careful. As you see, I'm in a stand so that the wheels don't touch anything. So this is important because otherwise your robot will go over all the places. So let's go. Backwards. Faster. There you go. There you go. And as you can see, it gives a duty cycle must have value of 0 to 100. So we reach the limit, but it's good because that way we have a soft coding so that we don't exceed the speed. And that's it. So this is how we move a robot DC motors through a Raspberry Pi. Okay, we're back. Leave in the video description all the problems that you had, and we'll try to respond them as soon as possible, or any improvements on the build that we've done for the moment. In the next video, we're going to add the camera, install ROS operating system, that's for sure, and then depending on the time, do a tiny tutorial on how to connect through SSH and maybe make a more rigid and robust build so that we can play around. And that's it. Until then, keep building. Keep building. Keep building. Oops.